most of you, if not by intelligence, by the fact that there aren't that many other things you could do, have realized this is a limiting sum situation, isn't it, right? And you probably could see that even before you knew what the question was, because you can see what the ratio is, right? So you remember, you get a limiting sum where if you take the absolute value of the ratio, it should be less than 1. This definitely fits that, right? The reason why it relates to this question is because the limiting sum is exactly what we're after. The limiting sum being what we approach as n tends toward infinity, right? Now, by the way, it's crucial that you get that little bit at the end. This is as n approaches infinity, okay? N can never equal infinity. Infinity is a very helpful imaginary concept for us and for mathematicians, but in real life, when you're actually giving medicine to someone, infinity is not a number you can get to, because you know the guy would die before you got to infinity number of doses. Okay, so this is important because of the numbers we get to later on, you'll have an important implication. Okay, so just keep that in the back of your mind. What is the limiting sum? The limiting sum, we'll just use S, is equal to A on 1 minus R, which you'll recognize is just the sum of a GP minus this bit on the top, which tends toward 1. Okay? Now, the reason I've gone straight here, instead of, for instance, getting a general term to n, sorry, that's a terrible question mark, is because this doesn't get me any closer to this, right? I already know what A and R are. Okay, so why are pirates called pirates? Because they are, right? Anyway, sorry. Now, what's the first term? What's the comma ratio, okay? Now, you do have to be really careful here, right? And this is why we build them from scratch. Think about this. How is this thing growing? What terms are getting added on, right? What's the term that stays still? The first term, okay? It's not going to be this term here. That term's growing constantly, okay? Instead, it's going to be this term on the end, right? So I'm considering, as we often do in financial situations as well, I'm considering the series in reverse, okay? So my A will be that 10 times 3/4, okay? Importantly, it's not 10 on its own, or 1, or something like that, okay? Which comes back to our definition of what we called M in the beginning. All right, on the bottom, we've got 1 minus the comma ratio, and now you just crunch some numbers, okay? Which arrives you at 30. Okay, now, the astute among you would notice, hold on a second. If I get to 30, that's at the end of, so I really should have called this M. It's a better name. I get to the end of some, whatever, interval, and I'm at 30, and then at the beginning of each interval, I should be adding 10, right? So when I add 10 to this, shouldn't I get to the number that I'm not meant to get to? So, can someone explain, why is the question worded correctly? Or how can we account for it? Why is it that I really never can get to 40, even though this is what the limiting sum is? Now, I'll admit, I kind of spoiled it for you before, right? By alluding to the fact that the limiting sum, it's a limit, right? So it's what you're getting to, you're approaching it. You never actually get there. Just like an asymptote, right? You can get close, right? But you never get there, okay? So saying the limiting sum, the limit of this is 0. I don't actually get to 0. In the same way, I never get to 30. Okay, so it's a bit tricky saying m equals 30, as if m was some real number somewhere. M is 30, which is real, just like an electric fence is real. Okay, but I can't actually get there. Since I can never get to 30, I can never get to 40 by adding 10. Okay, now it's important that you don't finish just here. Okay, because this doesn't answer the question, oh, you found a number, good for you, do you want a medal, right? I actually have to conclude in some way. Okay, so what am I going to say? I wonder what you put down, okay? If you put down anything. As the limiting sum, or maybe 4, for the end of each interval. is 30 milligrams. Okay. This is probably a long way of saying it. Maybe you don't have to include all this, but that means that the patient's body will never actually get to 30 milligrams, right? So the patient's body will contain less than 30 milligrams, right, at the end of any given interval. Okay? Therefore, adding 10, administering a new dose will never actually, will be less than 40 milligrams, right? Well, let's answer the question, right? Do you remember I said right at the beginning, okay, that here, this part here where we defined our terms would make things easier or harder for us, right? So I guess in retrospect, we probably could have made our conclusion a little more concise and not have to go with this 30, 40 business by redefining M. How would you define it? I suppose you could say at the beginning. Because actually, that's when you have the most, right? Because if you think about the beginning of the interval and the end, you've always got more at the beginning, because by the end, the second you've progressed, you're losing more and more and more.